Hello guys, I'm here once again with Regents physics questions, open-minded, that you can get in your Regents exams. So this question is from Regents January 2004. So the question says, a manufacturer's advertisement claims that their 1,250 kilograms, 12, 12,300 Newton sport car can accelerate on a level road from 0 to 60 miles per hour, 0 to 26.8 meters per second in 3.75 seconds. So the question says, determine the acceleration in meters per second. So meters per second is the unit of the car according to the advertisement. Okay, so we're trying to find the acceleration. So we're gonna use the method of gear to solve our question. And the number 66 says calculate the net force required to give the car the acceleration claimed in the advertisement. So number 65, we're trying to find the acceleration. So acceleration is the change in velocity over time. And if you don't remember that, you can check your reference table, and it's right here. Acceleration equals change in v over time. The little triangle means change. Alright, so the given. So we are giving the change in velocity, because velocity, the unit of velocity is meters per second. So right here we have our velocity. Oops, sorry. We have our velocity right here. 0. The change in velocity will be 26.8 meters per second because it changed from 0 to 26.8. And our time is 3.75 seconds. So our given G equals no. So our given is the velocity, which equals 26.8 meters over seconds. We also have our time, which is 3.75 seconds. So that's our given. Alright, so then we need to use our equation, which is the equation of acceleration. Change over t equals change over velocity over time. So our equation will be a equals, I don't know how to do that triangle, but I'll just draw it. Change in change in velocity over time. So that's our equation right here. So I'll just draw the little triangle. Little triangle right here. Boom, boom, boom. Alright. So now we plug it in. A would equal change in velocity, so it would be 26.8 meters per second divided by 3.75 seconds. So, bring our calculator out. So when we divide this, we get 26.8 over 375. So we get 7.146666666666666667. So instead of just writing that entire number, we could just round that to 7.15. 7.16. I mean 7.15. Alright. Alright. our acceleration will be 7.15 meters per second squared. Second square. That will be our acceleration. Okay. Alright, so now let's do number 66. Let me pause this. Alright, so let's move on to question 66. So 66 asks, calculate the net force required to give the car the acceleration claimed in the advertisement. Alright, so we're trying to find the force net. The net force. So the equation for net force is mass times acceleration. So we just found our acceleration, which is 7.15 meters per second squared. So since we have our given, so the equation for force net is F net equals mass times acceleration. And if you ever forget that equation, you can just go right to your reference table, and it's right here. Right here. Force equals MA. Mass times acceleration. Alright, so let's put this in red. Oh, never mind. Okay, hold up. Oh. You know what? Let's just rewrite it. So, F net equals, alright. F net equals mass times acceleration. Alright. So that's F net, that's the equation. Now all we gotta do now is plug it in. Alright, so we'll get the mass. So they're giving us the mass. So that should be in the given too, right? So because they're giving us the mass. Alright, so the mass will be 1,250 kilograms. So let's write that in the given. So mass equals 1,250 kg. Alright. Let's write that in the given so we don't forget. So now let's plug it in. So the mass is 1,250 times 7.15, which is the acceleration. Acceleration is 7.5 meters per second squared. Don't forget the units here, kg. So when you plug that in the calculator, you will get 1,250 times 7.5. Well, you square. Let's square the 7.5 first. 7.5 times 7.5 equals. Wait a minute, is that right? Let's do that again. 7.15 times 7.15 equals 51. What's going on? 7.15 squared. That should be. Okay, hold up. There's a problem. Something's going on. MA, mass times acceleration, times 1,250 equals, so we get a net force of 63903.15. Okay. Okay, so you don't have to square the 7.15. So it'll be 1,250 times 7.15, which gives you, because a Newton is kg times meters per second, so you'll get 8,937.5 Newton, because a Newton equals kg times meters per second squared. Alright, so we get, let's see, alright, let's plug this in here, and then we get a net force equals 8,940. That's what we got, right? Alright, we can round that to 8,940 newtons. Alright, so that's our answer. That's how you find the net force and the acceleration. So if you ever forget, don't be scared to look at your reference table, because all the equations are here. Like acceleration, change over time, and then F net. Alright, there we go. Force net, the F's, and then if you want to know what they mean, they're right here. Net force, F net. Alright, so let's move on. So we get a result of net force equals 890 newtons. Alright guys, thanks for watching. And that's it for the video.